Hello, it's great to be here today, so thanks for the invitation and let's start. Serverless, how to speed up tests over 300 times and achieve continuous feedback. Maybe just a few words about me. I'm Tomasz Konieczny, I currently work for RAW as senior QA engineer, and I'm mainly responsible for test architecture and infrastructure. And today's presentation will be related to both of these areas. But let's start with the basic question, why do we execute end-to-end regression tests? Or maybe, why do we execute regression tests in general? Because during the development of some new functionalities, it's possible that we will introduce bugs to already finished ones. And regression tests are intended to detect these possible bugs. But why do we need high-level or end-to-end regression tests? Because these are the only ones that can guarantee us that something is actually working correctly. That's why we need them. But at the same time, there is one serious problem related to them. I mean, they are really slow and time-consuming. And it's not only about QA's time or time of the development team that they will have to spend on these repetitive tests. It's also about feedback time. So basically, how long we will need to wait to get the results. And the second part may be even more important. Solution for that is automation. If we automate something that's repetitive, and regression tests definitely are, then we can save some time on this repetitive execution. The second thing is that automated tests can be way faster than manual ones. So we can execute them way faster, maybe even in minutes instead of hours. And if we have some automated build process, like for example some CI server, then we can get this feedback even immediately after every repository push at every pull request. And if we have some proper test coverage, then we can even think about going with CD, continuous delivery, or even continuous deployment. Because we have the tests automated, we can easily verify if the application is working fine, and we can make decisions based on that. It's great, isn't it? Well, then the problem appears. I mean, we develop the application, it becomes more and more complex, and it also means that we need more and more tests, and the test set basically grows. So, execution time also increases. 10 minutes, 30 minutes, maybe even hours. So basically, we have exactly the same problem. Tests aren't fast anymore. So let's assume we have some example. We have 500 Selenium tests, and the execution of each of them takes about 20 seconds. It means we need almost 3 hours to execute this whole set. How can we solve it this time? Well, we can think about test set redesign. So instead of running this whole complete test set every single time, we can create the smaller one and, for example, some reduced test sets. And we'll be able to do the basic checks on every pull request and run the full one maybe a few times a day. Or maybe we should think more about test pyramid. So maybe we don't need every single high-level test. Maybe we can replace some of them with mid-level or low-level ones. But what if we already have the proper test pyramid? So maybe less recurrent builds. Instead of running tests like at every pull request, we can run them just a few times a day. Maybe this feedback will be fine. But is it really our goal? So maybe the easiest solution, more compute resources. Instead of running just one test instance, one browser, we can run a few of them, maybe 4. So it will reduce the execution time from almost 3 hours to about maybe 45 minutes. But it's quite a long time. And we would also need to think about this whole infrastructure part, so infrastructure maintenance or scaling. And it may become quite complex. So basically my answer to all of these questions is just no, because these solutions aren't solutions at all, they are just like very basic workarounds. And in my opinion, the only real solution right now is to use cloud. But we should use cloud properly, so not again some virtual machines because we just know them. We should use services that are designed to solve specific problems, that will allow to solve specific problems. And definitely our goal here should be the parallel test execution, because that's the only way to really speed up these tests. But not like 4 or maybe even 8 instances running at the same time. I'm saying like hundreds or maybe even thousands of them. So basically the goal is to run every single test at the same time. And the easiest way to achieve it is to use serverless services, because we don't want to think about this whole infrastructure part. I mean, infrastructure maintenance, infrastructure scaling. We just have our code, or tests to be more specific. We want to deploy this code, trigger it, and get the results. That's all we need. So I used AWS Lambda. If you don't know it, it's the function service at AWS Cloud. It basically allows to deploy code in one of the supported languages, so Python, Java, Node, and a few others, trigger and get the results. That's all we need. And what's great about Lambda is the initial concurrency. So just after the deployment, we can trigger it from 500 to 3000 times, depending on the region, and we'll just get the results. What's also great is that we can separate our test code from the runtime environment, because we will have some default runtime environment, for example, Lambda for Python, or Lambda for Node, but we also need a few dependencies, like for example browser, where we will execute the tests, or some libraries. So basically, Lambda layers allow us to deploy these dependencies separately from the code. And now I will show you the example implementation of the concept I designed and introduced in a few projects. So I used Serverless framework. That's the great implementation of infrastructure as code concept. So basically, it allows to describe the whole infrastructure part as code in the repository and easily build it. I used it in combination with AWS Lambda to build the very custom test runner that can really significantly improve the execution times. I will now show you the proof of concept. I already have a few production-ready implementations that are used on production, but they are really complex and it won't be possible to show you like the very complete solution. But I will show you the general idea how to build a tool like this. So let's start with the infrastructure part. Let's start with these Lambda layers. So basically our runtime environment. Let's create Lambda layers directory where we will put all these dependencies. And let's create two more directories there, so Chrome and Selenium. And inside Chrome directory, we'll have the browser binary, so Chrome or Chromium browser. And we also have the Chrome driver, so that's the Selenium driver for this browser. And in the second directory, Selenium will have other dependencies, like for example, libraries. So in this case, these examples will be written in Python, so I just pip installed them into this specific directory. There is also one more file, Serverless YAML, so that's basically the description of the infrastructure, or this runtime part. Now I will show you this Serverless YAML file. So it contains the service keyword, so that's our service name. Let's name it Lambda Selenium layer, because there will be our dependencies for this function that we'll deploy. Then we have a provider keyword, so these are the provider settings, so AWS, runtime Python 3.7, that's the language version I used, region Europe West, and timeout 30 seconds. And then we have the description of Lambda layers, so we have two of them, Selenium and Chrome, and they are just mapped to the specific directories, so Selenium and Chrome. Next, the testrunner function, so that's the actual test code that will be executed. I tried to make it as simple as possible, so there is only one handler.py file. In real life, we would have like maybe even hundreds of different test files. We'll deploy every single test to every Lambda function, and we will just trigger one of them. But let's assume we have just one file here to make it simpler. And we also have the serverless YAML again, but this time for the function that will be executed. So let's start again with this serverless YAML. Service name, let's name it Lambda testrunner, because it will run the tests. App, the same. And then provider settings again, so AWS, Python 3.7 runtime, region Europe West, and memory size. 1 gig of RAM should be enough here, but we can increase it up to 3 gigs if it's needed. Timeout 30 seconds, again it should be fine. And then the function settings, so let's name this function lambdarunner, and if we trigger it, we will execute the lambdarunner function inside this handler.py file. We also need to connect these Lambda layers, so our dependencies here. So two of them, Chrome and Selenium, they will be deployed along with this code, so we will be able to reuse them during the function runtime. Now the handler.py file, so that's basically the test code that will be executed. We can implement some testrunner here on the function side. Let's start with the basic imports, so Selenium, WebDriver, and browser options, or Chrome options to be more specific, JSON library, because we'll be creating responses, and then we have definition of the lambdarunner function. There are two arguments here, so event and context. We'll be able to pass the specific test that should be executed on specific function, so we will have 500 different tests, we'll tag them from 1 to 500, and a single function will execute just the single test. So with these parameters, we'll be able to pass, for example, that this function should execute test number maybe 5. Then we have the test result storage, so it will just store the result of the specific test. Then we need to configure the Selenium, so options, we need to set the custom binary location, so in this case TMP Chromium, then browser arguments, so headless and disable def SHM usage are needed to be able to run Chrome browser or Chromium browser inside Lambda function, and there are also two more, so single process and no sandbox. They are really useful for performance purposes. They can significantly improve the execution times, so it's good to use them. And we also need to set the custom path to the driver, so in this case Chrome driver will be inside the opt directory. Then we will have the actual test code. I skipped this part because it would be just the plain Selenium. But we can print anything into std out here, and it will be returned to the runner, and then we just return the response, so this test result storage variable will return it to the runner. I tried to make it as simple as possible, so just 200 that the function finished successfully, and the specific result. And then the runner, so that's the code that will actually trigger these Lambda functions, will manage the test execution. Again, I try to make it as simple as possible here, so I will just show you a few main areas of this test runner. So invoke test method is the method that will invoke Lambda function. It contains just one argument, test case ID. So we will somehow load this data, maybe we will have some YAML file that will contain list of the test cases, and we will just pass it to the this invoke test method, for example, that it should execute test case number maybe 10. And it will set it as scheduled. We will have this test set loaded here, so that's this async set. We will mark specific test case ID as scheduled, so it's being invoked right now, and then we will invoke it with client invoke from Bottle3 library. So Bottle3 is the official SDK for Python for AWS, and we'll just invoke the Lambda function. What's important here is the invocation type. So request response is the easiest one to use. We'll just make the request and get the response directly, so the test results. But we will have to switch to the event later. I will speak a bit about it later. And there is also one more important thing here, so it's payload. So here we can pass the arguments to the Lambda function, so in this case test case ID, and that's the test case that should be executed. So basically the Lambda function will contain code for every single test. It will just execute the specific one of them. Then we mark the test case as executed because the execution finished. We save the response, parse it, and save the results. And then the thread for executor. So we will create 500 threads because that's the number of test cases we have. And we will invoke this invoke test method 500 times with different parameters from this async set. So for test cases from 100 to 1 to 500. And it will be invoked 500 times. It will invoke the 500 Lambda functions, and we will get the results here. So let's run it. I try to make this output a bit cleaner, so I just ran 5 test cases. I also skipped this implementation part for the reports because they are really simple to implement. So we can see some execution logs that test cases from 1 to 5 are marked as scheduled. Then they are marked as executed. The order is slightly different here because the Lambda functions finish in slightly different times. That's no normal thing. That's why we also have the report. So test cases from 1 to 5 are marked as passed, every single test passed, and we can see the summary and also execution times because I used the time command. So it took about 25 seconds to execute these 5 test cases instead of about 100 it would take normally. But I mentioned we have 500 tests and I ran just 5 of them. What would be the execution time for this whole complete set of 500 tests? It would be about 30 seconds. So we just improved the execution times from almost 3 hours to about 30 seconds. Well, maybe 40 if we include also the deployment time, because we'll have to deploy this Lambda function. It takes about 10, maybe 15 seconds. So it's really significant improvement. But what about execution costs? Because we just ran like 500 instances. What would be the execution cost? For this specific test set, it's about 17 cents. So if we compare it to the cost of the development team waiting to get the results, it's like really low and we can trigger it whenever we need. And what's even better is this proof of concept is quite simple to implement. I mean, it's about maybe a few hundred lines of code. So it's quite simple. It's definitely not some production-ready solution, but it's really depending on the project what you will need. So it's possible to extend it in quite simple way and just start using it. But what are the limitations of this POC? Well, the most important one is the API gateway timeout. Because as I mentioned, we triggered this Lambda function in request response mode. It means that we will get the results directly, but it also means that API gateway will be also used. And the timeout for it is about 30 seconds, which means that we can execute tests only up to 30 seconds. So we should fix this one. We will need to switch it to the invocation type event. The downside is that we won't get the results directly, so we will need to add some additional execution state storage. In this case, I used DynamoDB database. So basically, when I trigger a Lambda function, the test code is being executed, and after it finishes, then the Lambda function posts the results into the DynamoDB database. And the runner can get these results directly from the database, using, for example, DynamoDB streams to get just the differences. It's also possible to implement it based on queues or in any other way, but I already used DynamoDB for different purposes, so it was easier for me to just reuse it. And with this change, with different invocation type, event, the max execution time for the test is about 15 minutes, and it should be enough for almost any purpose. But how to extend this POC? Well, it's really dependent on the project needs, but I already made a few production-ready implementations, so I will show you a few basic concepts. So I use DynamoDB, as I mentioned, for some artifact storage, for some test logs. I also use S3 bucket for like heavier build artifacts, maybe some screenshots, execution logs, request logs, and also a few other things that are mainly related. There are a few other changes that are mainly related to testrunner, so support for thread limit, so number of concurrent functions, or ramp-up period, so the runner will start with the lower concurrency and it will increase it up to the target. So there were some project-specific things that were needed, but it's, as I mentioned, really specific to the project needs. And in the end, I will show you just two more things. Cloud is really powerful. It allows us to implement things that weren't possible earlier, or at least were really difficult, and you can do it in a really simple way. But at the same time, it's really important to think outside of the box. I'm not some cloud expert, I'm just a QA that uses cloud from time to time, and I was still able to implement something like this that really significantly improved not only the test execution times, but also the whole development process. So it's all about thinking outside of the box. If we will keep using things that we already know just because we know them, then we won't be able to really improve things as we are able. And it would be all. Thanks, I hope you enjoyed this presentation, and if you have any questions, I can answer them now. Thanks.